apart from all dispersion correction, meniscus correction, temperature correction, it is also necessary for immersion correction. So, when the hydrometer is measured or inserted into the suspension, the surface of suspension rises. So, you can see here, this is the distilled water here, and this is the hydrometer, and this is the immersion correction, and how we go for the immersion correction. This is what we want to discuss. So, immersion correction is applied by observing the increase in volume due to the displacement. The immersion correction is applied to determine the effective depth, and that effective depth is denoted by ZR. Now, immersion correction is calculated by VH by 2 of A. So, we can write like this: immersion correction, that is this is equal to V by H, this divided by 2 of A, where this VH is equal to, this is volume of hydrometer, and this A is cross sectional of jar containing suspension. So, immersion correction, we can use this equation VH by 2 of A. That means, VH is equal to volume of the hydrometer, A is cross section of the jar containing the suspension. Now, we require calibration of the hydrometer. This is important to calibrate the hydrometer, and how you can calibrate the hydrometer. So, hydrometer reads the specific gravity at approximately the depth in the liquid where the center of the volume of the hydrometer floats. The effective depth which we discussed, that is Z of R, of the center of the volume of the hydrometer corresponding to the hydrometer reading. That means, we can express that Z of R will be equal to H of 1 plus H by 2 minus V by H, this divided by 2 of A. That means, this H1 is the distance corresponding to hydrometer reading. H1 is the distance corresponding to hydrometer reading, this H1, and H, small h, is the height height of the bulb, and then this VH is the volume of hydrometer and this A is cross sectional area. Cross sectional area of jar containing suspension. So ZR, we can write H1 plus H by 2 minus VH by 2 of A. Since this depth must be used in the computational of particle diameter, and it is desirable to have a calibration chart. So, you need a calibration chart for this. So, this is the sedimentation jar with the hydrometer. So, here I can tell you this from here to here, this is ZR. So, this ZR is equal to this H1 plus this is H of 2, and this is VH by 2A, that is minus VH by 2 of A. So, this ZR, any reading in the hydrometer, you can first you distance corresponding to the hydrometer reading, that H1 you have to calculate. Then this is H by 2, that means H is the height of the bulb, and then VH is the volume of the hydrometer, and A is equal to the cross sectional area of the jar that containing the suspension. So, from this diagram you can also calculate that Z of R. This is other way, also you can see how to calibration of hydrometer. This is H and this is H of G. So, this is the lowest calibration mark here, and this is center of the volume of the bulb, and this is small h is the height, and this is calibration height. For any reading D1 you can measure 25, then 1.0025 like this 20. So, you can calibration this mark like this also. Also, you can use this calibration of hydrometer. This x axis, which is height from the center of the bulb of the hydrometer reading, that is in centimeter, and this is the hydrometer reading. So, that means 1.02, 1.02, 1.02, 1.015, 1.011 like this is the hydrometer reading. So, this the calibration of the hydrometer. So, knowing that what will be the height of the center from the bulb to the hydrometer reading, so you can calculate that what will be the hydrometer reading. So, you can calculate and can say for a particular value height of the center of the bulb. So, you can calculate hydrometer reading, let us say 1.02, let us say 11 when it is the height from the center of the bulb to hydrometer reading is 11 centimeter, then you are reading the hydrometer reading. For any height you can calculate that what will be the hydrometer reading. So, you can calculate this hydrometer reading. Okay. Now, for this we require the certain apparatus and the accessories. You recall long stem hydrometer that range about 0.995 to 1.030. You require electric high speed stirrer, then dispersing agent, for example sodium oxalate and sodium hexametaphosphate. Then graduated cylinder of 1000 millimeter capacity, which I have shown you, and then you record the distilled water, hot plate, then drying oven and the porcelain dishes. So, these are the accessories required for performing the test. You require also the balance of 0.1 gram accuracy, thermometer of 0.1 degree centigrade accuracy, then spatula, then evaporating dish, wash bottle, stopwatch, then 3-way pipette and the 500 millimeter measuring cylinder. So, these are the apparatus which you require for performing the hydrometer analysis. So, procedure for the hydrometer analysis, first of all you have to take about 50 to 55 gram of air dry soil passing through 4.75 millimeter sieve. Then determine the hygroscopic moisture content of the fraction passing through 4.75 millimeter sieve. You know that how to determine the hydrostatic moisture content, and then add enough water to soak the soil sample completely in a glass beaker and add 100 cc sodium hexametaphosphate solution. The warm the mixture gently for about 10 minutes. Now, transfer the mixture to the top of the mechanical mixture using a jet of distilled water to wash all the traces of soil out of the beaker. Then stir the soil suspension about 15 minutes. Transfer the suspension onto a 70 micron sieve placed on a receiver and wash the soil on the sieve using a jet of distilled water. Transfer that suspension to a measure cylinder and make up the volume exactly to thousands milliliter with the distilled water. Turn the measuring cylinder end over end, keeping the palm of hand firmly on the top of the cylinder. Now, start the stopwatch immediately after placing the measuring the cylinder on the table and take the reading at the interval mentioned in the record sheet, and then determine the meniscus correction which I explained earlier, how to calculate the meniscus correction, that is Cm, and then also you have to determine what will be the dispersing agent correction, that is C of D. Now you have to calculate the what should be the particle size diameter. Now as I explained you earlier that particle size diameter also can be determined within the equation, and that is particle size diameter. Let us say that particle size diameter is equal to D, that is particle diameter, that is particle diameter is D. So D will be equal to 10 into root of 18 into eta, this divided by 980 into 60 into Gs minus 1 into root of H by T. So this particle size diameter D can be expressed like this. So here eta is the viscosity, eta is the viscosity of water at room temperature. And small h is height of fall. And T is time in minutes. Time in minutes. And Gs is specific gravity of solid. You know how to calculate the specific gravity of the solid. You can also calculate that what will be the percentage finer N. So percentage finer N, say that percent finer N. So percent finer N also can be determined within this equation. N is equal to Gs divided by Gs minus 1 into Vs divided by W of S into R minus Rw, this into 100. What Gs is specific gravity of solid. You know what Gs is? Specific gravity of solid, and V of S is the volume of suspension. Volume of suspension is generally taken about 1000 milliliter. And Ws is oven dry weight of soil which is taken. And R, this R equal to corrected hydrometer reading. And RW is hydrometer reading in clean water. So, this is important how to calculate the percentage final. You can use this equation, N is equal to Gs divided by Gs minus 1 into Vs by Ws, R minus Rw into 100, where Gs is specific gravity of the solid and Vs is the volume of the suspension. Generally you take about thousands millimeter, and Ws is the oven die weight of the soil taken, and this R is the corrected hydrometer reading, and Rw is the hydrometer reading in clean water. So, combine of this result, whether it is the gravel and the fine sieve analysis, you have to calculate it. You have to calculate that what will be the percentage final N. So, percentage final N can be computed for the hydrometer analysis, is modified to N dash. That means that modified to N dash will be equal to N into N of dash G, this divided by 100. So, this modified N dash you have to calculate. So, this is shown the specimen calculation for the sedimentation analysis. How to calculate the specimen calculation for the sedimentation analysis. Okay. So, here we have calculated the meniscus calculation. Let us say Cm. I will show you how to calculate also the specific calculation. Cm is equal to 0.004 and dispersion correction CD is 0.0034. Hydrometer reading in clear water Rw is 0.996 and viscosity of water is 0.00836 poise, and BH by 2A is equal to 1.3636 and specific gravity Gs is equal to 2.54. So, you have to take the reading at a particular time. So, it is starting 0.5 minutes, then after that 1, 2, 5, 15, 30, 60, 120 and 40 and 40. Like that you have to continue. So, you inserted the hydrometer into the cylinder and then you can measure the hydrometer reading at a particular given time. So, for example that for 0.5 meter you are getting the hydrometer reading 1.016, or for an example that when the time is 15 minutes you are taking the hydrometer reading R is 1.01. Then you have to take R dash is equal to R plus Cm. Cm I say that meniscus correction. So, you have to do the meniscus correction. So, we do meniscus correction, that means meniscus correction Cm is equal to 0.004. So, you can add that R dash is equal to R is 1.01 plus mean square correction 0.004. So, it will give 1.0104. Okay. Then you have to calculate the Z R, which I mentioned, that how to, I can show you that how to calculate Z R, that is 16.1354. Then H will be equal to Z R minus VH by 2A. So, Z R is known, let us say 16.135, and then you calculate VH by 2A. This is VH by this is 2A, this calculation 1.3636. So, this is H is equal to Z R VH by 2A. So, if you can calculate that Z R is this and this minus VH by 2H 1.338. So, you can have 14.7718. Then V velocity h by t. So, you can calculate at what height and what is the time. So, for this time you know the height and you know the time. So, you can calculate that what will be the V, that is h by t. So, this is centimeter per minute. Now, this is R is equal to R dash minus CD, that is dispersion correction. So, dispersion correction is given 0.0034. So, R will be equal to the this whatever the R dash you are having here, okay, R dash 1.0104, and this minus that CD, that dispersion correction 0.0034. So, if you can calculate, you can have the value of the capital R. So, this capital R value will be equal to R dash is this minus CD is this. So, it will give this value 1.0070. So, capital R minus RW. So, you know that what is R value, and RW is the hydrometer reading in clear water, that is RW 0.996. So, if you subtract 0.996 from this R, so you can have this value 0.001. Now, this is root of h by t. So, you know that V, that means this h by t. So, if you take the root of h by t, that means 0.9924. And then I told you about the equation D, which is related with this. You can determine what will be the diameter of the particle. So, you can determine diameter particle, and then you can determine what is percentage fine art N from the earlier equation, and then you can correct it percentage fine art N dash, you can calculate 15.70 as I shown you that earlier equation. So, this is the earlier equation, N dash is equal to this, and also N equation we have shown this RW, this how to calculate this. Okay. So, this way you can calculate the specimen calculation for the sediment analysis is given here, and I can show you later on all detail about this, how you can calculate this from the hydrometer reading separately. Thank you.